distance versus time graph. Okay, in this distance versus time graph, we are going to identify some unique features in this graph. Okay, in here the horizontal axis will show you the time. Mostly time will indicate it in seconds. In sometimes it might be hours. Okay, it might be hours. In some cases it can be minutes also, but that's not more popular one. Okay, mostly you will receive your time in seconds or hours because the units for speed or velocity is in kilometer per hour or meter per second. So that's why we are going to receive time in seconds or hours. Sometimes it might be minutes also. Distance here I indicated the distance in minutes. Okay, distance in minutes. Okay. Here you can see there is a straight line graph. Okay, this is in the form y equals to mx. Okay, y equals to mx. That means this graph is going through 0, 0. The coordinate 0, 0. No? So that's why I indicated this is kind of graph y equals to mx, y equals to mx. Okay, don't worry about it. We will study what is y equals to mx, what are the characteristics of this graph. Okay, in the x-axis, in the horizontal axis, I was indicated time. You can see in the vertical axis that is measured in meters, that will give you the distance. Okay, distance. I was used white color lines to indicate. To travel 1000 meters, it took 250 seconds. Similarly, to travel 800 meters, it took 200 minutes. Likewise, this is the way we have to analyze the graph. First of all, what is our horizontal axis say? The important thing is units. Similarly, what is our vertical axis saying? What is its units? Okay, then in distance versus time graph, there's only component. There is an important component, that is gradient. Gradient or slope of this curve. Okay, what is gradient? Okay, to find gradient, just think about it. In usual y and x-axis coordinates, we have to use y coordinates difference upon x coordinate difference. So similarly here also gradient means, what is our y coordinates here? Y coordinates are distance. Okay, distance. It should be divided by what are the x coordinate values? That is time. Okay, distance divided by time. So the gradient will give you speed. Okay, gradient will give you speed of this straight line. Speed of this straight line, because as we already know, gradient is y-axis y coordinate difference upon x coordinate difference. Similarly, here our y coordinate is saying about distance, the relationship of distance. The x coordinates are indicated to represent time. So distance divided by time, that will give you speed. So gradient of this distance versus time graph is giving you speed of the object in motion. Okay, speed of the object in motion. That means this straight line will give you the motion. Motion means that is a moving object. Okay, moving object. At starting, that is in 0, 0 coordinate. Then within 50 seconds, that will travel to 200 meters. Similarly, within 100 seconds, it will travel to 400 meters. So this object is in motion. This object is in motion. These are the important features of this distance versus time graph. Okay. Then we will find speed. Okay. According to this, we know that gradient of this straight line will give you speed. Speed of this object. Okay. This object is moving. Okay. With respect to time, that is moving. So to find the speed, okay, to find the speed, you have to select a particular distance. Okay, when I'm asking you that the question at 200 seconds, find speed. Okay, find speed. find speed. So speed is equals to distance upon time. Okay, distance upon time. The gradient will give you speed, no? So the distance at 200 second. At 200 second, what is the distance that object was traveled? That is 800 meters. 800 meters should be divided by the time. The time it took to travel 800 meters. Okay, in the question they were indicated as 200 seconds. So we can use that. To travel to 800 meters, it took 200 seconds. So we can simplify this fraction to get our speed in the unit of meter per second. Unit of meter per second. Okay, I'll repeat once more. Slope. Slope or gradient of this curve will give you the exact speed. Exact speed. So here my question is at 200 second, find speed. Okay, to find speed, we already know slope or the gradient will give you speed. So distance divided by time. Similarly, at 200 seconds, okay, you have to draw a straight line through that and find the distance, how much it traveled. How much it traveled. 800 meters was traveled within 200 seconds. So these are the parameters. Then we will simplify this. Okay, this 0 and this 0, this 0 and this 0. And then we can simplify these two. 1 2s are 2, 4 2s are 8. So the speed at 200 second is 4 meter per second. Okay, 4 meter per second with the unit. This is the way you have to represent your answer. This is the way we can find this speed. Okay, that's all for this question, speed. Here you can see this is a straight line. Okay, this is a straight line. So speed in each of these place. Okay, speed in each of these place. Here I indicate some points. Okay, in each of these instances, the speed is same. Speed is same because the gradient is in the same slope. No, same slope. In some cases, it might be some curvature likewise. Some these kind of curvature likewise. We are not going to discuss those stuff. We are only discussing the straight line distance versus time graph. The straight line will give you the speed. That's how I found the speed as 4 meter per second. 4 meter per second. Not only in this place. Here you can see at this place. Okay, how can we find the slope of this graph? You have to draw a straight line and okay, draw a horizontal line. Okay, you should draw a horizontal line that will give you the slope. This angle, this is the slope. Similarly, when you measure the angle at every places of this straight line, all of them are equal. All of them are equal. So, speed in every positions, I indicated many position. In every position of this straight line, speed is constant. That speed we found it as 4 meter per second. 4 meter per second. That's all for this question.